So here we have a drawing of the unit circle, which is the circle of radius 1. And what we want to know is some of the properties of the points that lie on the unit circle, the points that lie around here, right? When we were looking at the Ferris wheels and stuff like that, right, we were in particular concerned about the height of our functions here. So it would be good, for example, to know something about the y values of points on these circles. And it would be nice to know something about the x values as well. And so we kind of want to establish some guidelines for how to think about the points on the unit circle and their x and y values. And the key here is that they all lie on the unit circle. So what that means is if I traverse some distance t and I come to some point here and I go, all right, great, what's my x and y values there? Then, well, this is my y value, right? It's how high I've gone in this case. This is my x value down here. Right, how far forward I am. And what we should note is that that's a right angle. Right? That's a right angle, and if I connect the origin to xy, in this case, this forms a right triangle. Now, we actually know a reasonable amount about this right triangle. We have one very, very important piece of information, and that is that because this point xy lies on this unit circle, its distance from the origin is 1, right? The distance from the origin for all the points along this thing is always going to be 1 because that's what the unit circle is. So what I have then is that x squared plus y squared has to be 1, right? From Pythagorean's theorem. We know for a fact that we have that, and so that can help us in determining values on this circle. So let's say hypothetically that I knew that y was 3/5, right? If I knew that y was 3/5, I'd like to know what my x values are in this case, right? And so if my y value is 3/5, what I do know is that I can come over here and say, all right, x squared plus 3/5 squared is 1, right? And in other words, x squared is 1 minus 9 over 25, which is 16 over 25. And that x is equal to plus or minus root 16 over 25, which is plus or minus 4/5. Now the plus or minus is not a trivial concern here, because if I look at points on the unit circle whose y values are 3/5, there's actually 2 of them, right? There's another one here, and this x value, so this is 3/5. This x value here would in fact be negative, right? So I have an x value here that's negative, 4/5, and then an x value here that's positive 4/5. But in this case, I'm aware that I'm lying in the first quadrant, and so both my x and y values need to be positive. Alright, so if I know one of the coordinates and I happen to know what sign the other coordinate should be, I can narrow down a specific value of y for every x and x for every y. So let's go ahead and just whip up another quick example. Let's draw another unit circle. And let's say I know that my x value is negative 1/2. And I want to know what my y value is. So I can draw a triangle here again. This is negative 1/2 down here. This is some y I don't know. Once again, my hypotenuse is 1. So what I know is that x squared plus y squared is 1, right? And so x squared in this case is negative 1/2 squared, which is 1/4. So y squared is 3/4, and y itself is the square root of 3/4, which I'm personally okay leaving like that, but it may be easier to rewrite as square root of 3 over 2, right? Plus or minus, right? And so the plus or minus once again refers to the fact that there's another triangle down here with the same x value but a different y value. One's positive, one's negative. We're aware that according to our drawing that this one should be positive, so we get square root of 3 over 2. If I was in the third quadrant, I would get the other value, negative square root of 3 over 2. Alright. Thank you very much for watching. I'll see you in the next video.